Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif bin Saifunizam. My metric ID is MA18108. I am from Klang, Selangor. I will continue from my part, which is introduction of the experiments. Basically, in these experiments, we consider the fluid frictions in pipes. The fluid travels slow at pipe wall because of friction created by pipe wall. Figures below shows the mechanism how the fluid flow across the pipes, and we can see that lamina sublayer there. The lamina sublayer is the fluid that moves slowly, and only the turbulent rapid flows allow the sublayer to form. Next, we continue for the problem statement of the experiments. Several challenges will occur over the course of this trial for have a good result at the experiments. So first one is if we need to find out how much the significant losses are worth, because without this information we won't be able to proceed to the next level. Next, we need to determine head loss in a small diameter plastic pipe and consider friction losses. Objectives of this experiment we have two. The first one is to explain the mechanics of fluid friction phenomenon in pipes. And the second one is to understand and apply basic knowledge of the major losses in straight pipes. The last one is the scopes of the experiments. To determine whether a laminar or turbulent flow will occur during the experiments. And the last scope is to investigate the effects of different pipes diameters on velocity. The friction factor will be linked to the range of flow rates. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Pratika binti Ahmad, MA18101. For the theory, the pressure loss in pipe flows is commonly referred to as head loss. Major loss refer to frictional loss, whereas minor losses refer to loss caused by fittings. The head loss for pipe flows are some of these losses. In Bernoulli equations, as shown above, HL represents the head loss due to friction between the fluid and the internal surface of the constant diameter pipe. As we can see here is the Bernoulli equations that related for our experiment. For next is the Darcy equations. Is the theoretical equation that determines the loss of frictional energy in a pipe depending on the fluid velocity and friction resistance. There are the different equations for the turbulent flows and laminar flows. So here we can see the equation for both. And the next is I will explain more about laminar flow and turbulent flows. The laminar flow is when every particle of fluid flow along one smooth path. The particles of fluid that do not interfere with one another, they don't mix or shift between the layers, as we can see at the uh, at the picture for laminar flow. And for the turbulent flow is when the flow of a fluid is irregular. Particles in turbulent flow can move back and forth between layers, and you can see at the picture below. For the Reynolds number is the ratio inertial force for viscous force. The Reynolds number is a dimensionless number used to categorize the fluid systems. For the Reynolds number here is the equation rho VD over viscosity. So that's all from me. Thank you.
Hello, my name is Kumar Esed, Analaki Mohana Ravi. Matrix number is MA18108. BMM352163, and today I'm going to explain about Chapter 3, which is Methods and Procedures. So firstly, I would like to explain about the equipment and materials used in this experiment. So the first one is the fluid friction apparatus, which we can see on the top right corner. And the second equipment used is data measurement. So we can see that there is a computer and PC, a CPU. So these are used to record and store the data from the experiment executed. So the third one is the pressure bench, and the fourth one is the hydraulic bench. Now I'm going to go through with the procedures of this experiment. So the first is a straight pipe was fitted in the system. Then all the open valves were turned to the left. Thirdly, to allow the flow of water, the pump was turned on. Then the desired volume of water was adjusted by adjusting the control valve. To run the experiment based on the data provided, the unused valve was closed. Then a pressure sensor was mounted in the system with the function of measuring the pressure. Then the value of water flow rate of on-flow rate was recorded in LPM unit. Then the next experiment was repeated from step 1 to step 7 using a 90-degree elbow pipe, 90-degree bend pipe, and 45-degree bend pipe. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ariz Amir Zainzam. My ID number MA18149. First, the lab 3, friction losses in pipe. So, I will present about result, graph, and discussion. So, this experiment we have two experiments. First, major losses in straight pipe. Second, minor losses using access software. So the given data, we have length of the pipe, PVC pipe internal diameter, PVC pipe thickness. During this experiment, we assume that room temperature is 25 degrees C, the density, and the dynamic viscosity. Next, for major losses in straight pipe, this is the data that we get from Excel. Second, experiment 2, the minor losses, elbow on elbow 90 degree. This is the graph for the measure heat loss versus calculated loss coefficient for bend pipe 90 degrees. Second, calculated loss coefficient versus Reynolds number. Third, equivalent length versus calculated loss coefficient. Second, for the bend pipe 45 degree, this is data. There are three graphs. First, measure heat loss versus calculated loss. Second, calculated loss coefficient versus Reynolds number. Third, equivalent length versus calculated loss coefficient. So the conclusion, the highest calculated loss coefficient between the three experiments under manual losses is experiments by bend pipe 45 degrees at 2.1824 as to compare with 1.3712 for elbow 90 degrees and 2.1354 for bend pipe 90 degrees. The reason is that the bend pipe 40 degree has a smaller arc radius compared to others, hence the sharp turn cause higher loss during change in direction. We get higher K value for elbow 90 degree as compared to bend pipe 90 degrees. Elbow pipe has a shorter length as compared to the bend pipe, hence contributing to sharper turns. The highest equivalent length is experienced by the bend pipe 90 degrees followed by bend 45 degrees and lastly elbow pipe 90 degrees at 0.2614 meter, 0.2600 and 0.1180.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Ahmad Wad Ibn Muhammad Azmi, MA18121. So I'm in charge to present my part, which is conclusion and reference. So for the conclusion for the experiment is finally there are certain distinction between theoretical and experimental results. Their variation could be due to the sensor inefficiency in processing fluid movement feedback. As a result of this experiment, we learned about fluid flow in a pipe with diverse system. There are between elbow pipe, bend pipe, and 45-degree angle pipe. Elbow pipe generates the highest net loss according to the data acquired from the sensor. So the result of experimental conclusion back up the theoretical calculation when determining which had the largest head loss. So we were able to determine which size and type of pipe would be appropriate for a given case at the conclusion of the trial. So the amount of flow has an impact on the loss within the pipe. So as the result, we could employ this method of experimentation in every industry sector to discover the best pipe condition. So lastly for the reference, so firstly we find from the Pasina O lab handout, BFEN 3310 major and minor losses print at 10 November 2015. So next is the second edition Fluid Mechanics Fundamental and Application, which is book by Yunus A. Singgala and John M. Simbala. It published on 2008. And lastly, it's from the Ahmad Zulkifli, UMP Knowledge and Learning Management System. At the login to the site, UMP Knowledge and Learning Management System. Login to the site 2021. So the link. So that's all from us. Thank you.